Hello friends, in the last lecture we discussed the effect of axial load on a member. In this lecture we will discuss the effect of eccentric axial load on a member. As we can see from the figure that a load P is acting on a member away from the longitudinal axis and the eccentricity is E. To know the effect of eccentric axial load on a member, let us discuss two loads P1 and P2, which are equal in magnitude as P and opposite in directions. To know the effect of eccentric axial load on a member, let us consider two loads P1 and P2, which are equal in magnitude as P and opposite in directions. We can see from the figure that load P and P2 generate a couple which tries to bend the beam along with the length of the member and load P1. So, an eccentric axial load creates an axial loading and a bending moment. So, as we see from the figure that due to the eccentric axial load, there is hogging in the member, which creates normal stresses and bending stresses in the member. As we know, the value of axial stress, which is sigma axial, is equal to P1 upon A. As we know, the value of axial stress, sigma axial, is equal to P1 upon A. As we can see from the figure that due to the eccentric axial loading, there is hogging in the member, which creates a normal stress and the bending stresses in the member. As we know, the value of axial stress, sigma axial, is equal to P1 upon A. Similar effect of bending moment will produce bending stresses in the bar, which is sigma bending is equal to M upon Z, where Z is the section modulus. From the diagram, the bending stresses is positive in the upper section and negative in the lower section of the member. Hence, the resultant stresses at the upper and the bottom section of the member and the resultant stress at the upper section is equal to sigma T max, which is equal to sigma axial plus sigma bending. Also, the resultant stress at the bottom section is equal to sigma T minimum, which is equal to sigma axial minus sigma bending. Hence, we can say that from the bending formula, M upon I is equal to F upon Y, which is equal to E upon R, where sigma max is equal to P upon A plus M into Y max the whole upon Ix, which is equal to P upon A plus P into E into Y max the whole upon Ix. Sigma minimum is equal to P upon A minus P into E into Y max the whole upon Ix. Hence, sigma max is equal to P upon A minus P into E into Y max the whole upon Ix. And sigma minimum is equal to P upon A plus P into E into Y max the whole upon Ix. In this lecture, we discussed the effect of eccentric axial loading in the member. In the next video lecture, we will discuss the effect of transverse shear load. Thank you for watching this video. Please do subscribe and like our channel, Ekeeda.